And we found that the key to making this technology work for folks is to work closely with the community to get great ideas and get feedback. And that's certainly been the case this summer. And we thank everybody who's participated in that as part of the team in that respect. So I'm just going to say just very quickly for, I know some folks are joining who are part of the co-design program. Some folks are joining who may not know anything about Clew at all, or may not know, maybe just saw a link on AppleVis or Reddit and decided to jump on this presentation. So I just want to say really briefly, what is Clew? Because that's going to set the stage for some of the talks that you're gonna listen to. So Clew is an application that uses your smartphone to record routes in indoor environments. And crucially, these routes don't need GPS in order to be recorded. So it uses your phone's camera and the sensors in your phone in order to track your phone's motion as you move through space. Once you've navigated along a route with the Clew app, you can stop the route and save it so you can use it later, or navigate back to your starting position. So this could be useful navigating unfamiliar environments. For example, if there's an environment where you interact with like a sighted guide to go somewhere, you can return on your own to your starting location, or there might be an area that's difficult to navigate using traditional orientation mobility skills like using a cane. And in that case, Clew could help guide you. So Clew is always meant to be used as an augmentative tool to cane or a guide dog, and not as a replacement. And so it's really been designed around that use case.
Yeah. Hi, everyone. Welcome. My name is Fernando Victorio, and I've been working with Paul Ruvalo throughout the research program. The demo day is a culmination of our 10-week research program, so congratulations to our research team who's been working on various aspects of the technology platform. Because Clew is a smartphone app, what we've created is a technology platform that enables us to capture data, or what we call rich data, directly from the user, obviously with permission from the users, to improve the performance of the app, but also understand how the app works in the context as it's being used by someone who is blind or low vision or partially sighted. And so with our program over the summer, we have teamed up with co-designers from around the world. These are folks who are either technology enthusiasts, they're blind or low vision, they may be working in various fields in technology, but we also have representatives from various organizations for the blind across the world, people who are specialists and trainers in orientation and mobility. So we bring together a diverse skill set from within the blind and low vision community to actively take a seat at the table with our researchers and helping plan, design, experiments, even feature development, and then providing feedback. So it's much more than just user testing. This program basically brings in folks from outside of our community onto the actual research team to then advance and accelerate the pace of the research that happened over these past 10 weeks. So we're very excited to share with you our research results. A lot of these projects are still ongoing. So what you're hearing is basically, stuff, results and progress that is still continuing. And we wanted to bring this to the community so that you can actually have a chance to participate, to learn, and then to also connect with us. So if you're new, we definitely encourage you to reach out to us. There are a lot of opportunities to join or collaborate in the future. And we look forward to hearing from you.
So hello, my name is Declan Ketchum. I am an engineering student here at Olin and on this research team working on Clew. So I focused mainly on learning Clew and creating a Clew tutorial. Back to difficulties with using Clew. As with any new app or technology, there's a learning curve to getting to the point where you need to get to the point to feel confident and comfortable using said technology. Clew is uniquely challenging because it uses augmented reality and needs data from your phone's camera. For Clew to work, it needs visual data of the space in front of you, which is not always intuitive, especially for someone who is not using visual information to move around anyway. In a study conducted in previous years, we found that people reported having bad experiences using Clew when their phone was not oriented vertically with the rear camera facing directly in front of them. This experience makes sense because the app uses data from the phone's camera to create a route. It also shows that we need to do something to improve the experience of using the Clew app. We also observed that it can be difficult for people to adjust the phone to the correct orientation without feedback, outside feedback, or practice using Clew. Another difficulty that we heard from our users and from our wonderful co-designers is that the anchor points in Clew, which Paul talked about, are confusing, especially at first, which makes many of the features in Clew difficult to access. So on the right-hand side of this screen, there is an image of what the Clew tutorial homepage looks like. It has a button for each section that has contents of what you would learn. The sections are first an introduction to Clew that includes information on what Clew can be used for, along with some limitations and disclaimers about Clew. In this section, there's also an introduction to the tutorial itself. The next section is on holding your phone, where the importance of your phone's positioning is explained, and there's an interactive exercise where you can practice holding your phone in the correct position. Following that, there's information on finding and following a Clew path, such as an explanation of what it should sound like when you're on the Clew path, along with 2 short practice routes that you can try out without ever having to save a route. In the next section, there's information on using single-use routes, and followed by a section on anchor points. Anchor points are explained along with the importance of accurately aligning them. And then there was also an opportunity to practice setting an anchor point and then realigning to that anchor point that you set. The tutorial then gives you feedback on how close you were to the initial anchor point. After this, there is an explanation of saved routes, and then an explanation of where you can find your saved routes after they've been saved and stored in a list. And finally, there's a page on what the settings of Clew are and how you can change them. So here's an example of what one of these practices would look like. One second, I'm going to start a video. So this video shows the tutorial homepage. We're then going to click on the holding your phone section of the tutorial, where there's an explanation of why it's important to hold your phone in a specific way while recording and navigating routes. There are some buttons below that will take us to different pages, and we're going to click on the practice button, which takes us to an interactive practice page where there are instructions that say, here you will practice holding your phone in the correct position for recording and navigating routes. Click start and try moving your phone around. You'll see that the further you are from holding your phone upright, the more your phone will buzz. And when you get to the right position, there will be a success sound and you'll get a point. To get more points, you'll have to move your phone out of the correct orientation and back into it. To do this, or try to do this at least 3 times. So now that we know what we're going to do, we're going to press the start button. The video just needs to catch up with us here a little bit.
Tracking performance normal.
So right there, you could hear what it sounds like when you're holding the phone in the incorrect position. It makes a lot of, it like beeps at you. And if you were holding the phone, you would also feel some haptic vibration, which would kind of cue you to try holding it in a different position. So that's what that sounds like. Here, so if you heard that shift in the sound, that's what it sounds like as you're holding it more correctly. It starts beeping a little bit less. And here, this is the correct position. So just there, I got 1 point. I was holding it in the correct position and it gave me a success sound that accompanies 1 point. And so now I would have to move it out of the correct position and then back into the correct position to get another point. So when doing this practice, you would try and get 3 points, and then you would get a notification that you've completed the holding your phone practice, and you can continue to the next section. Okay. So some next steps for this tutorial is to get some feedback on how people feel about this tutorial and how they're using it in its kind of more completed state, and then push this tutorial onto the main app so that anybody who's using Clew can use it. And we also want to be able to collect information on how this works as a teaching method by conducting a study in the future.
Hi. So I'm Merwan.
And I'm Neil.
And we are part of the depth prediction and machine learning team. So advances in machine learning over the last couple of years have allowed for a lot of new advancements in accessibility tech that weren't possible before. So some examples of this are Microsoft Seeing AI, which is kind of a multi-tool app where you can sort of scan your phone around and take pictures of the environment, and it'll give you descriptions of what's in it, or you can scan handwriting and it'll tell you, convert it to text. Things like Apple's image description through their own voiceover, where again, you can describe what's inside of an image, and auto captioning of audio. There's a few examples of machine learning's applications in accessibility technology over the last few years. And now, given all of this, we feel like we can use machine learning to improve our own accessibility apps. So currently our apps use Apple ARKit, and ARKit has a ton of useful tools, which we love to use, but they're closed source and not really modifiable. And specifically, scene depth understanding without a LiDAR sensor is limited. So we'll get into what that means specifically in a little bit, but basically right now, the ability of a phone to understand how far away an object is dependent on texture and the motion of the phone. So our main goal of the summer was to replicate LiDAR technology on a non-LiDAR phone. So some of the new phones like the iPhone 12 Pro and iPhone 12 Max or 12 Pro Max have LiDAR, or light detection and ranging technology. So a LiDAR sensor uses a pulsed laser to measure ranges of objects around a room. And this technology can be used to detect how far away objects are from the device with very high accuracy. Now, in phones with LiDAR, ARKit is capable of finding how far away objects are very accurately, but in phones without this technology, we don't get the same ability. So we really wanted to find out if we could replicate LiDAR technology on a non-LiDAR phone. So our main method to do this would be using a machine learning model to detect depth of objects in a single frame from just a single camera input. So a good way to think of this would be as like a software LiDAR, or using software to emulate what a LiDAR sensor would do. And with this, we can do a lot of things like obstacle detection and path correction in the Clew app.
Have a demo. So this is the app in action. So I'm just going to freeze the frame for a second. What is going on? So in the video, we see there are two buttons on the top of the screen for meters and feet, depending on what unit of measurement you want to have the app read out to you. Currently, the app is being demoed in a classroom. In the image, there is a chair as well as a few tables and some cardboard boxes, and there's like a back wall in the later frames. And below that image is the heat map that is being processed by FCRN Live. So in the heat map, it is a black and white image where the objects that are closer to the camera are displayed in whiter pixels, and the objects that are farther away are displayed in darker pixels. So
Feet, 4.2.
So this is
4.5.
So I've selected feet as the unit of
5.2.
measurement, and I am backing away from the
6.5
chair. And
meters.
So
1.9.
oh wait, that is so loud.
1.9.
So as I was backing away from the chair, the voice started to like display that I was backing away from the object by saying that the distance was getting bigger. Now I've turned my camera towards these cardboard boxes and switched the measurement to meters. So as I get closer to these boxes,
1.5.
Yeah.
1.6. 1.1.
Yeah. So as I got closer to the boxes, it started to see that we were getting closer to the boxes by changing the depth. Okay. There we go.
So thanks to our meetings with co-designers, we were able to get a lot more clarity on what we should do with the future of this app.
Hello, everyone. My name is Arvan Najashi, and I've been working on Clew hands-free feature over the course of the summer. So let's get started. Here is a quick demo of the presentation of the Siri shortcuts.
Start single-use route. Hey Siri.
So this video has showed me holding the phone vertically against my body. Okay. So this video has showed me holding the phone vertically against my body. The camera was facing forward and I used Siri shortcut to start a single use route. I didn't have to interact with the screen. It was all through using voice commands. All right.
Hi, everyone. I'm Esme. And I'm Berwin. So this summer, we've built an extension of Clew that we're calling Clew Maps. Clew Maps builds on the existing functionality of Clew as an indoor navigation app to better support sharing routes and navigating unfamiliar spaces. So this slide is a demonstration of the recording, uploading, and navigating functionalities of Clew Maps. The video has a camera feed of Berwin recording a route, or Berwin completing these tasks on the left-hand side, and a screen recording on the right-hand side. We have voiceover turned on in the screen recording and also a narration of what's happening in the video. So please let us know in the chat if there are any issues with the audio.
First up is a demo of recording the route. The first step of recording a route is to enter its associated app clip code ID, which is the 3-digit code that tells where things are in the database.
Scan NFC app clip code button.
Here, Berwin's doing that by scanning an NFC tag.
Enter text to help you remember this app clip code ID saved. You may now set an anchor point. Successful alert. Start recording.
Next, she aligns to the image anchor and starts
Start to begin recording
process.
route. Start button. Stop recording. But anchor point saved. You
The
are now
rest of
recording a route.
recording looks
Hold
like
vertically with the
recording
rear
any
camera
route
facing
in-
forward. Stop. Up. Clew home screen. Route success. Enter route. Save route. Enter route name here.
Berwin's now
Text
stopped
field.
the
Insert
route and is
T.
naming it
Cap T.
to
E.
upload
S.
to the database.
S. T. T. Save route name. Clew home screen. Route. Load routes from app clip.
Next up is uploading a route.
Voiceover on. Clew map. Access the routes on your device. But access the routes on your device. Local save. Route test. Button.
Uploading a route is done through
Upload
the
route
Route Manager
button.
view. Lastly, we have navigating a route. Since
Load routes
Berwin's
from app clip
navigating
code
through
ID.
the app
Button.
rather than the
Load
app
routes from app
clip,
clip code ID.
the app clip
Scan an
URL
NFC
hasn't
app
been
clip code.
invoked yet, so
Button.
she's having to add
Ready
in
to scan.
the app clip code ID manually.
Successful. Left turn. L.
Now
Right
she
turn.
can select
Test.
any of the
Button.
routes that have been
Test.
uploaded to this location
Start
in the
navigating.
database.
Start navigating. Please align your device with the camera pointed at your anchor image. If you are using the Clew app clip, this will be in the same location as the scanned app clip code. Your route navigation will start immediately after your device has anchored to the image. Stop
After
turn
scanning
left.
to
Align to
locate
anchor
the
point. Starting
image
navigation.
anchor, she's automatically aligned and can begin navigating just like a normal Clew route.
Record voice node. Button.
Hello, everyone. Thank you for coming to our demo day. We are the Invisible Map team. My name is Allison.
And my name's Ben. So what is Invisible Map? Invisible Map is meant to be a map of an entire building. This contains the position and orientation of markers throughout the building, the position of breadcrumbs or places you can walk within the building, such as hallways or inside rooms, and the position of name locations, such as specific classrooms, the bathroom, water fountains, etc. So the idea is that while routes like in Clew can navigate you from A to B, and they have to stay directly on the path, and they can't kind of inform each other. So for instance, if you had two routes in the same building that overlapped, they wouldn't be able to learn from each other. So the idea is that maps can be from anywhere to anywhere within a specific building. And because of just the nature of hallways and branching, this means that it can allow for detours or helping you when you get lost. And because it's one kind of collection of information with essentially a ton of different possible routes you can take, it's a much more efficient use of information.
So the markers that Ben mentioned just earlier are called April tags. They're essentially these small codes that are similar to QR codes. It's an 8x8 grid of black and white squares. They all have a very unique pattern, so they're easily identifiable. And the most important thing about April tags is that the phone can easily identify the position and the orientation of the tag. So similar to the image anchors that the previous group was talking about, the phone is able to identify where this tag is as soon as it detects it within the camera frame. And the big useful thing of that is that if you chain April tags together, so you detect one and walk some more and then detect another, the phone can store the locations of these tags. And then when you re-navigate your route, if after scanning the first tag, the path starts to drift a little bit as you walk further, as soon as it scans the second tag, it can reorient the path and put it back on the right track. This is a big disadvantage that happens in Clew, which is that because Clew does not have any relocalization, sometimes the path will drift. So this allows us to make much bigger paths through a space.
So the Invisible Map suite has two apps, Invisible Map and Invisible Map Creator. Invisible Map Creator is an app to help people create these maps. So very similar to Clew, users will walk through an entire space. They will also have to record tags that they have hung up around the space so that we can learn the location of them. This is also where users will save locations to name and come back to. In the future, it will be where you can edit maps and change locations. And finally, it's where you can upload the maps for processing. Invisible Map is for people who want to navigate the maps. So you can download public maps, download your own maps, eventually share maps with friends. And this is the much more Clew-esque app where it can navigate you through the building.
So we have a demo of Invisible Map Creator and Invisible Map. When I walked the Invisible Map route, I essentially first started up the app. And then as soon as I open up the app, it comes to a list of maps. And then from there, I can select create a new map. And then that will bring up my camera. This video is sped up for the sake of time. It brings up my camera, and the first thing that it instructs me to do is point my camera at a tag. So I point the phone at a tag, and as soon as I point it at its first tag, once it detects it, it displays a visualization and also instructions saying that you found your first tag. And then there's a button that says start recording tags. I hit that button, and as soon as you record a tag, it will add it to the map and restore its location. Then as you continue to walk along, the same process repeats. So every time it sees a tag, it displays the visualization, lets you know, you hit record, and then it will store the tag position. What you can also do is store locations. So I also add a location at the women's bathroom by hitting the add location button, typing a name, and then hitting save. That will drop a pin at the women's bathroom, and then later on I will be able to come back to that. And then I continue along using the creator, and then at the very end, I circle back to where I start, record my final tag, and then save the map, give the map a name, and then this will upload it to the backend processing. Then in Invisible Map, I start up the Invisible Map app. So in a couple minutes, it finishes processing. I start up Invisible Map, and it pulls up the same list of maps that I've created. I can find the map that I just made and click on it, and then that will start up the app. And then there's another button that says start tag detection. As soon as I click that, it will start looking for tags in the camera frame. So it finds my first tag, and it plays that little audio cue. Oh, what? Sorry, the video just glitched out a little bit. It plays the little audio cue at the beginning that indicates that the navigation has started. Currently, there's no verbal feedback, but there is audio cues and haptic cues of a beeping. This video is also sped up, but the stronger the audio cues and the haptic cues, the more aligned you are with the path. It shows the same red path that Ben was talking about previously that navigates you to your destination. And the big important thing to notice in this demo as well is that when I initially scan the first tag and I start walking, the path starts to drift just a little bit as I continue to walk, but then my phone passively detects the second tag. And as soon as it detects that second tag, it moves the path to be back in the right position because it knows where that tag is supposed to be. And so it shifts everything back in place. And then so that's that live correction that we were talking about that allows longer routes to work. And also as I pass by the women's bathroom, the little location marker that I put there is also there. And then I just walk the path all the way to the end, and at the end of the path, it also plays an audio cue to indicate that I've arrived.